Hello dear students, welcome to my YouTube channel. So today we will be discussing this chapter light. So this chapter light is there in the class 10 CBSC, ICSE is also there, and in class 12 also we have this chapter. So this will be a brief revision type of video for those students who has already finished the chapter. Even for class 12, mostly the students, they find difficulty while solving the numericals, drawing the ray diagrams and so on. But for that you need to understand the basics. So in this video I'll be discussing the basics first. Okay, so once we are done with the basics, then we will do the numericals, we'll do the ray diagrams, and whatever question and answers are there we will solve so that you can prepare well for your exams. So what is light? Light is a form of energy that makes things visible for us. So we know that we can see with our eyes, but in order to see things we need the presence of light. So light is nothing but its energy which makes things visible for us, right? So the next thing that you must know is what is a ray of light. A ray of light is nothing but it is the path that the light takes while traveling from one point to the other. So as we know that the light travels in a straight line, so a ray of light can be represented as a straight line and with an arrow. So this arrow is important because this shows the direction in which the light is traveling. So here the ray of light is going from left towards the right. Now the next thing is what is beam? So ray is the path in which the light travels, or the path taken by the light to travel. So when we have a number of rays, that is collection of rays, then we call it as a beam of light. For example, so here if we have this rays, all the rays going in one direction, then this collection of the rays of light we call it as the beam of light. Now light has various phenomena. In nature we can see various phenomena related with the light. But here first we will discuss about reflection of light. So we all know what reflection is. We have seen reflection of light whenever we see ourselves in front of the mirror. Whenever we see the still water, we can see images formed on the water, surface of the water. So all these are because of the reflection of light. So reflection, if you have to define, then we can say reflection is the phenomena of bouncing back of light when it strikes a smooth surface like mirror. Which means whenever light falls on a smooth surface like a mirror, then it gets bounced back. It goes in the same medium. So this phenomena where light bounces back to the same medium when it strikes a smooth surface, we call it as the reflection of light. So in this diagram, you can see that we have a plane mirror here. So when a ray of light comes towards the mirror, so this ray of light which comes towards the mirror, we call it as the incident ray. So the ray of light which comes towards the mirror, we call it as incident ray. Now when this ray is incident or falls on the mirror surface, it reflects back or it bounces back to the same medium. And this ray of light which is going away from the mirror, we call it as the reflected ray. So here you have to know the definition of incident ray and reflected ray. Incident ray is the one which is coming towards the mirror. The ray of light which strikes the mirror is called as the incident ray, and the ray of light which leaves the mirror after it strikes the mirror, we call it as the reflected ray. Now we can draw a perpendicular line at the point of incidence on the surface of the mirror. Yes. So I have seen most of the students, they make mistake here. They say normal ray. So this line which has been dropped perpendicular to the surface. Perpendicular means it has to make an angle of 90 degrees here. So this normal is nothing but a perpendicular line dropped on the surface of the mirror at the point of incidence. So we have three things here in this diagram. We have incident ray, we have reflected ray, and we have normal. Mind you, this is not a ray. This is a line which has been dropped perpendicular to the surface of the mirror. Now we can see that this incident ray makes some angle with the normal, and this angle we call it as the angle of incidence, and we represent it with letter small I. And this angle that is formed between the reflected ray and the normal is called as your angle of reflection, and we represent it with angle or letter R. So in this first diagram, as I've already explained, that when a ray of light strikes a smooth surface like mirror, then it gets reflected back. So the ray which comes towards the mirror, we name it as incident ray. The ray which goes away from the mirror, we name it as the reflected ray. and the line which has been dropped perpendicular to the surface of the mirror, we call it as the normal. So the form between the incident ray and the normal, we call it as angle of incidence, and it is represented by I, small letter I. And the angle between the reflected ray and the normal, we call it as the angle of reflection, and it is represented by small r. So this is the case when a ray of light falls on a smooth surface. Now what happens if a ray of light falls on a rough surface? That means the surface is not smooth like the first picture, but the surface is rough. It's not plain. So what happens when the ray of light falls on a rough surface? Does it get reflected back or not? Does reflection takes place here or not? So the answer is, of course, the reflection of light will take place. So whether it is a rough surface or whether it is a plain surface or it is a rough surface, light will get reflected back. Depending on that, we have two types of reflection. One, the first diagram that you can see is the reflection from a plane surface. We call it as this reflection of regular reflection. It falls on a smooth surface, the reflection that occurs, we name it as regular reflection. But if light falls on the rough surface, then we call it as the reflection of light. Here. So suppose the ray of light strikes at some point here. Right? So here also, this one we can call it as the incident ray. The ray which goes towards the surface, we call it as the incident ray. And because of the nature of the surface, it goes or gets reflected back in this direction. So this is your reflected ray. Now here, if you have another ray striking the mirror at some different point, let's say here, then this ray which is coming towards the surface is called as the incident ray. Then after reflection, let's say it goes in this direction, is the reflected ray. In case, if we do it here for regular, if we take another ray, then go in this direction. So this one is your incident ray, this one is your reflected ray. So from the diagram, it is very clear that there is some differences. When the light strikes a smooth surface like mirror, and when the light strikes a rough surface, then reflection of light will take place, but the difference will be, in regular reflection, the incident ray and the reflected rays will be parallel. But when it falls on a rough surface, even if the incident ray may be parallel, depending on the nature of the surface, the reflected rays may not be parallel. It may go in different direction. So here, the reflected ray may not be parallel, but here the reflected rays are parallel. So that is one difference between regular and irregular reflection. Regular reflection takes place from a smooth surface like mirror, and irregular reflection takes place from a rough surface. Now we have two laws for reflection of light. Whether it is a regular reflection or irregular reflection, we have laws of reflection. So the first law, it says that the incident ray, the reflected ray, and the normal at the point of incidence, this is the point of incidence. So the incident ray, the reflected ray, and the normal at the point of incidence all lie in the same plane. There are three things: incident ray, reflected ray, and normal. At the point of incidence, they all will lie in the same plane. Whether it is regular reflection or irregular reflection, the same holds true. Now, the second law of reflection is important, which says that the angle of incidence is always equal to the angle of reflection. So whether it is regular reflection or irregular reflection, the angle of incidence and the angle of reflection. So here also angle of incidence and angle of reflection, these will be always equal. So that means laws of reflection will hold good for both regular reflection as well as the irregular reflection. Now, since we are discussing about the reflection of light, we discuss about the mirrors also. So we have basically two types of mirror. These two types of mirror are plane mirror, and the second mirror is called as the spherical mirror. Students, they say that there are two types of mirror, which is convex and concave, which is not true. Convex and concave comes under spherical mirror. So there are two categories of mirrors that we see: plane mirror and the spherical mirror. So plane mirror, the one which we use in our everyday life, so that is a plane mirror which has a surface which is plane, and spherical mirror we see this in the laboratory. And there are two types of spherical mirrors, as I said. The one which has reflecting surface curved outside, we call it as convex mirror, and the one which has reflecting surface curved inwards, we call it as the concave mirror. So this is the category of the mirror. There are two types, plane mirror and spherical mirror. Spherical mirror further has two types, convex mirror and concave mirror. Now, what is a spherical mirror? Spherical mirror is a mirror whose surface, if we extend it in all the direction, then we get a sphere. Sphere means like the shape of a football. So if a small section of a sphere is cut and one side is polished, then we get a spherical mirror. So depending on which side is polished or which side has the reflecting surface, we can have two types of spherical mirror. If the reflecting surface is outside, for example, so this is your side is polished, that the light can be reflected from the outer side only. So here this reflecting side is on the outer side or curved outside. So this type of mirror we call it as the convex mirror. And if the reflecting surface is curved inside, surface is this side, the light will be reflected from this side, which is curved inside. So if the reflecting surface is curved inside, we call it as concave. In a spoon, we have two surfaces. From the side which we leave the food, that side is concave, and the outer side is the convex surface. So you can relate convex mirror and concave mirror with the spoon also. Now there are various terms that we have to know about the spherical mirrors. So this is required while doing the numericals also and while doing the ray diagrams. So if you know the terms and if you know the symbols, then it will be helpful for you. So let's discuss the terms one by one. So as I said, spherical mirrors are of two types. So convex mirror and concave mirror. So these parts are available both in convex as well as concave. So the first term that you must know is the pole of the mirror. Now what do you mean by pole of the mirror? Whether it is a convex mirror or a concave mirror, we have the center of the mirror. So the center of a spherical mirror, we call it as pole. So if you have to define, we can define pole as it is the center of a spherical mirror, right? So in the diagram, let's see what is pole. So whether it is a convex or a concave mirror. So this side is polished for a convex mirror, is polished for a concave mirror. Here the reflecting surface is outside, here the reflecting surface is inside. So whether it is a convex mirror or a concave mirror, the center of that mirror, we call it as the pole. And very important, the term or the letter with which we represent pole. So pole is always represented with capital letter P. So again, pole is nothing but it is the center of a spherical mirror. Now the next term that we must know is the center of curvature. The center of curvature is represented by letter C, and if you can see, the upper one we have a convex mirror, the lower one is a concave mirror. Now spherical mirror is a part of a sphere. So if we extend this in all the directions, then what we will get is a sphere. So for concave mirror also, if we extend it in all the direction, then what we will get is a sphere. Now this sphere will have a center, whether it is concave or convex. As I said, spherical mirror is a part of a sphere. So if you extend this in all the direction, then we will get a spherical surface like the shape of a football, and that sphere will have its center, which we call it as the center of curvature. So center of curvature is nothing but the center of the sphere of which mirror is a part. Here you can see both these centers are the center of the sphere, and mirror that we have drawn is a small section of that sphere. Center of curvature is defined as the center of the sphere of which the mirror is just a part or a section. The other term is radius of curvature, which is represented by capital letter R. Now we know that in a circle, the distance from the center to the circumference is called as the radius. So here also, the distance between the center of curvature and the pole, we call this distance as the radius of curvature. So whether it is a convex mirror or a concave mirror, the distance that is there between the center of curvature and the pole, we define it as the radius of curvature. Another term is principal axis. Now principal axis is an imaginary line that we can draw passing through both the pole and the center of curvature. So if we draw a straight line that passes through both the pole and the center of curvature, then this line we call it as the principal axis. So whether it is a convex mirror or a concave mirror, straight line that passes through the pole and the center of curvature, we call it as the principal axis. Now next is focus, which is represented with capital letter F. Now the definition of focus is different for the two mirrors, that is convex and concave. Let's understand it through the diagram. So the first diagram that we have is a convex mirror. So the center of this mirror is pole, and the center of this sphere of which this mirror is a part is the center of curvature. Then we have this line passing to the pole and center of curvature, which is called as the principal axis. Now if we have incident rays which is parallel with this principal axis, rays are parallel with the principal axis, and since these rays are striking the mirror, the rays get reflected back, and after reflection these rays will go thus. So if we follow these reflected rays backwards, then we will find a point on the principal axis here, and this point is called as the focus, which is represented by F. So how do we define focus for a convex mirror? Focus is a point on the principal axis from which the rays of light appears to get diverged. Diverge means to go in different direction from a single point. So as you can see, these reflected rays, it appears as if it is coming from here. It is getting diverged from this point, which we call as the focus. So let's again define focus. Focus is a point on the principal axis from which the reflected rays appears to diverge. So for this region, convex mirror, we also call it as the diverging mirror. Of convex mirror is diverging mirror. While doing the new notice, sometimes instead of mentioning convex mirror, they will mention diverging mirror. So you have to understand that it is a convex mirror. Similarly, if we have a concave mirror, and if parallel rays are incident on this mirror, so this is one incident ray, this is ray, and these two rays are parallel with the principal axis. So as the reflecting surface is inside, these rays after striking the mirror will get reflected, and after reflection it will go in this direction. It will follow this path. Remember, we need to draw the arrow because arrow shows the direction in which the ray is moving. So ray of light is moving in this direction, it strikes the mirror and reflected back in this direction. Similarly, this ray of light, after it strikes the point on the mirror, it gets reflected in this direction. So here again, we will see that the reflected rays are meeting at a point, and this point we call as the focus of a concave mirror. So how do we define focus for a concave mirror? It is a point on the principal axis at which reflected rays will converge or intersect. Converge means to meet at a point. So for that reason, concave mirror, we also call it as mirror. The other name is, we call it as converging mirror. Because it converges the parallel rays of light at a single point, which is called as its focus. So the diverging mirror, convex mirror, converging mirror is your concave mirror. Okay, next is our focal length, represented by small f. Now students often make mistake while using the symbol for focus and focal length. Focus is represented by capital letter F, and focal length, if you have to represent it with small letter f. So whenever you are writing focal length, the symbol should be small letter f. So focal length is nothing but it is the distance between the pole and the focus. In both the mirror, whether it is a convex mirror or concave mirror, the distance between the pole and the focus, we call it as the focal length. So focal length is the distance between the pole and the focus. And the last term that we have to understand is aperture. Now aperture is nothing but it is the surface of the mirror. Whatever surface the mirror has from which the light can be reflected, we call that surface of the mirror as its aperture. So aperture is nothing but the surface of the mirror from which the light can be reflected. Alright students, so that's all for today. I'll come up with more videos more topics in the next videos. As this is my first video, do like, share and subscribe my channel, and also give me positive feedback so that I can improve the method of teaching or whatever topics you need for your preparation in the exams. So please do comment and share your feedback. Thank you.